everybody. What we're doing here is a nostalgic AA gas engine build, kind of period correct, sort of like back in the day. The guidelines that we're following basically are from the Nostalgia AA Gassers Club. Some of the highlights of that are cast iron block, cast iron heads, 671 blower, no funny business inside of it, typical bottom outlet opening, no high helix rotors, magneto, 20% overdrive, alcohol allowed, and maximum of 500 cubic inches, and that would basically encapsulate. So what we're leading to is a new build that we're going to do something special. I've decided that I'm going to build a big block Chevrolet this time because I've never done one for AA gas racing. I've done small block Chevys, Hemis, and like small block engines from 370 cubic inches to 400 cubic inches, 398 Hemi, and now I'm going to build a big Chev of a larger cubic inch range. In this build, economy, I'm talking dollars and cents, is first and foremost. Everything's going to be, for the most part, used core pieces, heads, block, crankshaft, not rods, not pistons, not a lot of the valve train, but trying to keep things, economically cheap in mind. Okay, so at the end of the day, this engine is going to go into John and Aaron Reed's 1933 Willis that was built by Grant Kimber at Summit Metal, and it will be a Nostalgia AA Gassers Club car. Hopefully the program's going to turn out successful, and it may run hopefully high 490s in the 8th. So what we have here is basically the used bow tie case just before dropping the crankshaft in. As you can see, everything's lubed up and ready to go. Michigan 77 bearings, studs, all the normal stuff you guys are used to. The blocks obviously being clearanced for rod clearance. It had a 4,500 arm in it at one time. And I guess if I was going to point out anything special here, is just to make sure that you properly deburr the bottom of the cylinders so you don't eat your pistons up when things are changing direction. The camshaft, by the way, is a 4/7 swap. I had a little trouble with crankshaft thrust. I had to play with things a little more than I normally would. As you can see, the dial indicators on the crankshaft, and I had 4 thousandths thrust, 5 thousandths thrust at that point in time. When I put the cap on, it tightened up to 3, and that concerned me. So I had to, there's a dowel pin on number 5 cap, and I had to extract the dowel pin in order to get the clearance I wanted. So you check your thrust with no rear cap on, then you put it on and check, and it should be the same. Okay, now you can see crankshaft laid in. It's all torqued up and ready to go. This is our $300. Actually, this crankshaft was $150. That's what we paid for it, and it is standard on the rods, believe it or not, and 10 on the mains. And there was more money spent on it on the balancing, as you can see by the bunch of holes that are in it, than the actual core was worth itself. The rear cap, I spent a bunch of time on this, billet steel cap, but it still had quite a sharp edge on it, and so anything that had a sharp edge anywhere in the oiling system that I could get at, I took the time to break the edges and radius them with a burr, and final polish them with a polishing cone. The reason is to enhance flow. wherever there was entry from one point to another. And then on a sidebar, there are certain areas in this engine, particularly the lifter galleries, that run a traditional restrictor to keep oil down in the bottom end and not up in the valve covers. The beginning of degreeing in the camshaft, obviously off the intake lobe and on number 1. But what I'd like to point out is that it took the time to put in a nice screen to catch any broken lifters, which we hopefully won't ever have. You just want to try and protect the cam if you can. You can see it's a nice coarse screen that'll catch large chunks but allow oil to return to the crankcase. Keith Black gear drive, cam thrust set now, it's all buttoned up, cam timing's done. The dome of the piston, it is a diamond piston, beautiful product. Some people may question the gas ports, but this is my own personal preference. I want to seal the thing as best I can. It's a good light piston. I say light in that it's not naturally aspirated light, and it's not supercharged blown like 3,000 horsepower style piston. It's a spray piston, what I've used. The connecting rod and piston assembly before it is installed. Little marks on the bearing are my dowel gauge, verifying the clearances that I decided I was going to run. That we're using Bill Miller rods, which is one of the best connecting rod manufacturers in all of America. And again, nice shot from underneath. You can see the detail of the diamond piston, cleavite coated bearings here. Cylinder bore just prior to installing a piston rod assembly. A couple things to point out. This block on the deck had been cut for a receiver groove, which I decided to fill. About the bore, you'll see a greenish tinge to the wall surface, and that is the Total Seal break-in powder put on the walls prior to, again, inserting a piston. So here is the final assembled short block rotating assembly, all in and torqued up. All right, pump installed, checking pickup to oil pan bottom clearance here. For all you gurus, here's our stroker crankshaft. These are GM cylinder heads, open chambered, just basic. I picked them because they were cheap, and I felt that after the head porting that was done, I had enough airflow capability to make myself happy. You'll note that I've plugged the exhaust heat riser with my own mix. Shows some of the minor work that I performed on the port. Here's a shot of the combustion chamber and the intake bowl with enhancements that have been done. You note a nice multi-angle valve job and blend into the chamber, blend into the bowl. Likewise on the exhaust, the slight difference is that the valve job has a radius seat. I'll just tell you what's in here. Inside out, we have Rev Severe Duty stainless valves, intake and exhaust, Crower springs, Comp 10-degree locks, Cobra rocker arms, standard ratio, and I don't know whose girdle. I got it off eBay. Here's a shot of lifter oil shield that will keep the hot oil off the intake manifold and keep the charge air density a little bit cooler. Some people have seen them and some people haven't. They're GM performance part. The manifold required port matching, and so here's what you got. Another eBay item here. This is an old hamburger pan that has a screen and a wiper and a rear oil baffle to stop the oil from climbing up towards the crankshaft, and in the middle of the pan, a nice forward baffle. Was a good deal, 150 bucks. Okay, we got really lucky on the Supercharger. This is a piece from the past, magnesium, built by Don Hampton originally. I found this at RBS Superchargers, and the good folks out there had gone totally through it. They had repolished it and Dow 7'd it, and it's a beautiful nostalgic piece. If you notice the rotors, they've been hard anodized. They're stock GM cast rotors with 18-point strips cut into it, set for alcohol clearance. There are many other things that could be done on this blower to step it up. I could do the blower porting to it and a few other enhancements, but I didn't feel at the time, or at this time, it was worth doing. Let's just see what we got. On top of the Supercharger, you're going to note the Enderley circa 1958 through 65 barn door injector. I was told by Mr. Enderley that there was maybe 220 of them made. Kind of retrofitted everything and upgraded the bearings and the shafts. They were noted for having problems in the early days of possibly sticking the throttle wide open. And they worked through that, and we just took it one step further, making it 2017 with all the bearings in it. The barrel valve assembly came from Ron's fuel injection. Kind of comes in a raw form. You have to do your own cuts and returns in the spool valve yourself. And the hard lines were done by myself, circa Crower style injector. Completing the fuel system, we basically are working with a guideline that keeps us from getting carried away with anything we wanted to really do, and so the fuel pump rule is either 150-1 Hillborn, or as pictured here, an Enderley 80A-1. Note on the camshaft, I'm not going to tell you what we got in here, but I will tell everyone one thing. On an engine, any of the engines in this type of racing, if you're going to make any decent power, you can run no less than 270 degrees at 50 intake duration. And on like a small block Chev or a big block Chev anyways, I'd have at least 10 degrees more duration on the exhaust at 50. On this particular build, trying to keep the valve train alive, we are running 700 net lift. That's what I thought. I heard something start, you know. Looked like it came right out of the fucking.
Oh, the plug wire fell off.
Yeah. Yeah, and I got to tell you right now, like expectations, we had none, and I'm basically shocked. Car idled, oil pressure sounds great, everything's running fine. Owners John and Aaron Reed are in shock mode right now. Numbers that we've got say it's a 4-second car all day with lots of potential. Couldn't be happier.
Yeah, you're smiling. I'll tell you, I had to pull my heart out of my throat. Our first real scary pass.
That's nothing I've ever experienced before. That's like, I thought we had power 2 weeks ago,